function of the other one, but you just don't know, it's not written explicitly solved for that other variable, okay? Normally, we pick y to be the dependent variable, so you treat it as if y is some function of x. I just don't have right in front of me what the exact formula is, but I want to keep remembering that y is some function. So when I take the derivative, I take the derivative of both sides. Okay, so we take derivative of both sides. And I get 2 times x plus, now careful, if we read that second term, it's 2 times x times y. So you need to use the product rule. You have the function 2x, okay, so you have the function 2x is multiplying the function y. So first times the derivative of the second, and you just are going to denote it either with dy dx or with y prime, plus the second times the derivative of the first, and the derivative of 2x will be 2. Okay, so this whole thing is because we took the derivative of 2 times x times y. And then the third term, y is some function of x, and it's plugged inside of a square. So minus 2y is taking the derivative of the outside, and then times y prime is the derivative of the inside. And then the derivative of x will be 1, and the derivative of 2 will be 0. Again, this right here is the derivative of y squared, and I purposely wrote it with parentheses like that to kind of emphasize the square was the outside function, the y was the inside function. Then you want to collect all the terms that have y prime. 2y prime minus 2y, y prime, and move everything else over that does not have a y prime, so minus 1, minus 2x, minus 2y. Anything that did not have y prime in it, I subtracted. And then once you get that far, you can factor out the y prime. And then to finally get the derivative, so either your dy dx or y prime, whatever notation you're using. Here we go. Okay, so what that's telling us is given any point on that curve, if I plug x and y in, it will give me the slope at that point. And I thought I graphed all of these on your handout. I don't think it's not. Oh no, that, yeah, okay. But here's the graph. Yeah, the graph is on your paper. So here's the graph, and on these often when you try to find a point, you're not going to necessarily find nice clean coordinates. But given any point on the curve, whether it's here, or whether it's here, or whether it's here, or whether it's here, this formula will tell you the slope at that, at that point.
So when you took the derivative of y squared, why did you times it by the y derivative.
For the same reason that if you had been given a problem like the cube root of sine of x, the derivative of this would involve multiplying by 1/3, because that's the power, cube root's a 1/3 power, and then you would subtract 1 from the power. So I'm taking the derivative of the outside function, and then the chain rule says multiply by the derivative of the inside function, which for this example would be cosine of x. So for the same reason the cosine of x is sitting here, this y prime is sitting here. Because y is some function of x that's inside, this was your outside function. Y is plugged into that, and it is some function of x. We just don't know, like over here, I knew the inside function was sine of x. In this situation, I don't know exactly what the formula is, but I know it is some function. And so this is the placeholder for this. So I know that I need to multiply by the derivative of the inside. I just don't know what the exact formula is. Therefore, I put a placeholder in for it.
When it came to getting y prime on one side, rather than move the x values, I moved to the y values.
Yeah.
And that gave me what I think is the right function, but it's different. It's 2x plus 2y plus 1 all over 2y minus 2x.
Yes, you are correct. That these are equivalent to each other. You multiply the top and bottom by the, basically you just have the opposite of, so yes, and I agree, your version is cleaner. So that's better.
Would you do that? I mean, because you, as far as, I'm a little confused on why you use the chain rule on the y squared. Because you don't.
You have to think a little abstractly. I mean, that's the problem. I mean, when first getting introduced to this topic, you have to think abstractly. So instead of explicitly being given a formula where they tell you what the inside function is, instead, this.
Because that's a
Sorry,
function of
I
x.
moved the original. Hang on, I moved
It's
the.
right, it's right there. The whole.
Oh yeah, you're right.
It's right there.
Yeah.
You could use it
Oh,
right
yeah,
there.
okay, yeah. Okay, this y is a placeholder for some formula. I just don't know what the formula is at the moment, but y is some function of x.
Oh, okay, so if it was, if all that was some function of y, then you could do the chain rule to the x.
Yes, exactly,
Okay, okay.
exactly,
All right.
exactly. One, you have to interpret one as a function of the other, otherwise, I mean, that's really how you create a graph. Like, you create a graph by saying, okay, give me an x, plug it in, that gives me the y, I'll plot that point. Give me another x, I'll plug it in, that gives me another point, I'll plot that point. Give me another x, I'll plug it in, that gives me another point, I'll plot that point, and then you connect all the dots. So one of the variables has to be a function of the other. Since we normally plug x's in to get y, they follow that standard. But mathematically, it doesn't matter. It's just like what you said. You could say, okay, give me a y, I'll then figure out what the x is, and then we'll plot that point. Give me another y, I'll figure out what the x is, we'll plot that point. If we were doing that, then we would do the chain rule with respect to the x. Okay, but I know at the beginning it forces us to think a little abstractly, and it's I mean, that's why doing a lot. Usually, people are asking the same questions you guys are asking, and they're mulling it around, and then after we start to do problems, and they kind of get used to the mechanics, it starts to kind of make more sense. That's what I often see. I don't know if they make these anymore, but years ago, there used to be these posters called Mind's Eye posters, and they just look like some graphic art, but if you stared at them for a while, you started to see a picture. So it's kind of like that. You know, if you stare and think about it a while, it starts to come clear.